levers, I want to go about humans, and we'll pretty well wrap this section up. Basically, humans move through a series of systems of levers. Okay, basically, a lever is a rigid bar, turns around an axis. Okay, or a fulcrum point. Axis is the point of rotation. Okay, levers rotate about an axis equal to the resultant force applied to it. Okay, against some resistance or weight, like we saw in the previous examples. Right? Basically, in the body, the bones are the bars, right? The joints are the axes, and the muscles contract to apply the force. Right? Resistance can be minimal or maximum depending, okay, maybe only the bones or the weight of the body segment, okay. But typically they have all lever systems have three components, possible arrangements. So what you have here, it's called what they call a first class level, okay, where the fulcrum is at the point of rotation here. Right? You have force here and resultant. Right? F is a force applied, okay, R is the opposite resistance application. Right? Second class lever, okay, here's your fulcrum point here, right? So what you have here is the resistance is between the axis, okay, and the force A, okay, here. Right? And with third class lever, so lever is better than level, all right? That's essentially here again, A is the fulcrum point, F is the force applied, and R is the resistance, okay, which is futile. And I'll show you some examples in the human body, but these are the basic three types of levers in the human body. Again, the third class lever here you see here is your resistance here and your force here, opposite. Okay, these two together. Now, what about the human body? Okay, here you have again your FA, which we refer to as FAR, force, fulcrum, resistance. Okay, second class lever, A, R, and F, okay, resistance and F here, and your force. Right? And then what the other one have is your AFR, which is referred to AFR. Okay? So here's your force arm. See where you're talking about the force arm here? From this distance to here. In this case, it's from here to here. And in this case here, it's basically the difference between this point and that. So kind of explain how these things work. Does it make sense, everybody? You think? Here I just put some conversion factors, and a mechanical advantage is basically, again, we said that earlier, right? We have resistance divided by the force, okay, or the force arm length divided by the length of the resistance arm, okay, mechanical advantage, right? And these are just some conversion factors, just to kind of put them in there, but they're in your handbook. So, again, knee joint and mechanical advantage, right? With the femur, here's your tibia, this is your thigh, okay, and this is your what do they call that? Tibia. And then here you have your elbow joint and mechanical advantages here. Here's your M, okay. Here's your force, okay, depending on what it is. Kind of, we'll talk about elbows and knee joints here in a minute. Right? Kind of went through this already.